Okay, let's look at this problem. The temperature inside a balloon is raised from 25 degrees Celsius to 250 degrees Celsius. If the volume of cold air was 10 liters, what is the volume of hot air? Now, it doesn't specifically say this, but we're going to assume that the pressure is going to be the same. The pressure inside a balloon is equal to the pressure outside the balloon. So the pressure is going to stay constant, and since it's a balloon, the number of moles inside the balloon is going to stay constant as well. So as always, the first thing we want to write down is what we have. So we're given our initial volume, the volume of the cold air balloon at 25 degrees Celsius, which is about room temperature, is 10 liters. When it's heated to 250 degrees Celsius, what is the new volume? Well, we cannot do anything until we add 273 degrees to our Celsius to get our temperature in Kelvin. Okay, once we get our temperature in Kelvin, then we're going to use Charles's law. And we're just going to plug in V1 over T1 is equal to V2 over T2. So our initial volume is 10 liters. Our initial temperature, 298 Kelvin. Our final volume, we don't know. I'm going to call that X. And our final temperature, 523 Kelvin. Okay, now I'm just going to do my 060 math. I'm going to cross multiply. So I'm going to get 10 liters times 523 Kelvin, and that's going to be equal to 298 Kelvin times X. Okay, so I'll still leave it in red. So what that gives me is 5,230 liters times Kelvin is equal to 298 Kelvin times X. Since this is my unknown, I want to divide both sides by 298. So I'll use a different colored pen so you can keep track. Where's my pen? There it is. Okay, so I'm going to divide by 298 Kelvin and the other side by 298 Kelvin. And my Kelvins cancel out, and my 298 Kelvins cancel out. So I end up with X on my right-hand side, and then I'm going to take 5,230 and divide it by 298. When I do, I get an answer of 17.6, and my units are liters because my liters did not cancel out, and that's what I want. I want units of liters. So I'm going to put my answer up here and see, does this make sense? 17.6 liters. Okay, well, I went from a low temperature of 298 Kelvin, to a high temperature of 523 Kelvin. So my volume of 10 liters went up to 17.6 liters. So yes, that absolutely makes sense, because as I increase my temperature, my volume should increase.